This is one of our color digital oscilloscopes displaying an electrical signal and how it varies with time along the axis here. So that's voltage up and down, and that's time along the axis. And the fact that it's yellow means that it's recording on channel 1, which right now is the only one that we have hooked up to a cable. So the signal's coming in on this cable and it's plotting it out here on the screen. This allows us to see what's going on much more quickly than if we used a multimeter and in much more detail. So there are a couple of things to notice here. Down here it says that we're on the 50 millivolt scale. That means that 50 millivolts is the voltage in between one of these dotted lines and the next dotted line. So the whole screen would be 50, 100, 150, 200, 400 millivolts tall. Using this scale knob here, I can change that scale. I've now made it smaller, 20 millivolts. There I was back at 50 millivolts. Or I can increase it again to 100 millivolts. So that just allows me to make sure that things fit on the screen the way I want them. The position knob lets me move the trace up and down, just basically changing where 0 is when it plots it on the screen. And that can be really useful if I want to have two things on the screen. Now time, this says that our time scale is 10 milliseconds. So going from here to here is 10 milliseconds. Over here on the horizontal, we can change the scale of time. So I just made it 50 milliseconds per division, back to 25 milliseconds per division, 10 milliseconds per division, 5. Now, what does this represent? Well, right now we'd have to go and find out what the other end of this cable is attached to, and it's actually not attached to anything right now. And did you notice the signal changed when I picked up the end of the cable? When it was over here beside the oscilloscope, it was getting a bunch of noise out of the inside of the oscilloscope. So for us to get a signal that actually makes any sense, we have to connect this to something. I'm going to connect it to my Arduino, and I've got the blue wire here plugged into the ground connection on the Arduino, and this alligator clip here on the probe should always go to ground. And then I can measure what's going on elsewhere on the circuit by connecting this tip of this probe to some other circuit, some other point in the circuit. So I'll clip that tip onto this orange wire, which is going to the red power supply from the Arduino. So we're not going to measure anything very exciting right now. Now, one important thing to notice is that these probes, some of them will have a marking on them and some of them will have a switch like this one. These probes have different settings for attenuation, and we want to choose the ×1 attenuation. So make sure you move this red switch so that the little arrow here is pointing to ×1. Or if you get a different probe, there'll be a similar adjustment that you can make. So now let's set this aside and go back and look at the signal we've got. Well, we don't have a signal anymore. What do we do? Well, if I didn't know anything, I would count on the machine to do the right thing, and I'd press this auto set button here and see what it does. It's going out, it's looking at the signal and figuring out what it looks like. It gets something like this. So it's on a 20 volt scale, it's looking at it at 10 milliseconds. That doesn't seem right. So we better run through making sure how to get the setup right for this particular device. So let's go to the channel 1 menu. Coupling. Well, right now it's got DC coupling. I'm going to switch to AC coupling. I'll push the button here and set that up, because I'm only interested in the part of the signal that's noise, not the absolute magnitude of the signal. I'd better make sure my probe is set right on the oscilloscope as well. I need to set the attenuation to match what I set on the probe, and that should be 1 times. So I'll say go back now, and now I can adjust the scale a little more. I'm starting to see some interesting stuff on there. So that's what the noise on top of my power supply signal looks like. If I had DC coupling, then I wouldn't see anything unless I adjusted the scale way up. Now I've got 5 volts per division starting at 0. I've got a 5 volt power supply, so that's right. But I really want to look at what's happening on the AC side so that I can see just how much noise I've got on that signal. Then I can zoom in and see that on the 2 millivolt scale here, I'm getting quite a lot of noise showing up. So there's a fair bit of noise, several millivolts of noise on my power supply from this Arduino attached to the system it's attached to. I'd like to know some more about this signal, so let's add some stuff to the measurements on this screen. I can choose the measure menu up there. I can choose channel 1, and I'd like to know the peak to peak. I'd like to know what the mean is, and I'd like to know what the RMS is. That's basically the standard deviation of the signal. So I've added some measurements, and they're going to show up down here at the bottom so that we can see what's going on. So those are the skills you're going to use in the lab to make some measurements to find out how large the noise is in different parts of your Arduino circuits.